So now let's look at a graph of an exponential function. And I'm going to graph what probably in every single textbook when you're first introducing doing graphing. So I'm going to let the base equal 2. It's just a nice number to work with. But the reality is it could be, again, any real number that's greater than 0 and not equal to 1. So if I want to graph this, well, I need points. So I'm going to choose these very deliberately. I'm going to choose -2, -1, 0, 1, 2, 3, 4. Okay, just to get the basic idea here. And so if I enter f of -2, what do I get? 2 to the -2 power. Again, now recognize that, hey, that's a negative power. I can flip this to the bottom and then square it. So what I have is 1/4. So the output here is 1/4, and I keep going. F to the -1 is 2 to the -1. Again, I see the negative power. That means flip it from numerator to denominator, and I get a half. So yep, a half. F of 0. Well, 2 to the 0th power is 1. I keep going. Enter a 1. 2 to the 1st. 2. And again, notice how nice using function notation is, but I can see what my input is. I can see what my output. So these two form an ordered pair. I can just put them here in a table, but again, these form an ordered pair. But again, this is the nice thing about function notation. I can clearly communicate to the reader what's happening, and you can communicate to yourself later. Again, notice the way I'm doing it. I write what I start with, then the next step, then subsequent steps, but I don't repeat. I leave this nice and blank. So I don't want to write here. I want to leave this empty because therefore my eyes can focus. What this is telling me, here's where I started with, and every single step below that is equivalent. So now I can see that this is equivalent to that. So now I can see that I started with f of -2 and the result is 1/4. So there I made the connection without cluttering this thing up. If I start cluttering this thing up, then visually this makes it hard to read. Every time you write something, your brain must interpret what it means. But by leaving a blank, it lives the image of what I started off with. If I write f of -2 here and then again here, I'm repeating the same thing and it just gets cluttered. It's unnecessary because I already know what I started off with. But every time I have to look and see what's here and I go, oh yeah, it's the same thing. Yeah, it's the same thing. It just looks cluttered. This looks nice and clean, and this is the way you should write. Enter the next one, f of 2. So I got f of 1 is 2, f of 1, 2. Again, notice how nice this is to keep track of. F of 2. 2 to the 2nd power is a 4. So again, it's becoming a little easier to read. F of 3. I get 9. And notice each time I'm trying to create a space, if I were to just push this up here, if I go f of, try to jam it in here, now notice mentally it's hard for me to look at that. Now I have to mentally make a break. Like visually, my eyes are saying, ignore this. I need to just focus on that. But so don't jam, work together. Leave space when you mean to start something new. So go way down here, f of 4. I'm not sure why I wrote a 3 here. See, also easier to catch mistakes. What I meant to do is a 2. See how nice that is. And of course, now I'm messing everything up. But it's easy to catch because I entered a 3. I realized what my original function was, and I realized I'm making a mistake. So again, doing this thing nice and neat, and with this notation allows you to catch errors real fast. So 2 to the 3rd is 8, and 2 to the 4th. Okay, that's going to be 16. I'm not going to have these memorized, of course, but if you don't, that's okay. Start multiplying. 2 times 2 is 4, times 2 is 8, times 2 is 16. And there's my points, and now it's a matter of just graphing these. So notice at -2, here's -2. I have 1/4, so it's very tight. I mean, you can barely see where it's located. Here's -1, and it's a half. I can see that a little better. And at 0 is a 1. And then at 1, just right here, I get 2. And so I'm going to mark 2 right here just to be clear. At 3, 2, 3, no, at 2, sorry. Yep, at 2, it goes to 4. At 3, yep, just got to make sure I get to 9. 9. If I only have 4, I'll get to 16. Right, so it's got 10, 11, 12, 13, 14, 15. Yeah, it's just broken up by ones, just verifying. And there's my exponential function. So you can see that this is climbing extremely fast. And why? Because I'm multiplying. Unlike a linear function, which I'm just adding, it takes a while to increase. But for a exponential function, I am multiplying. And we're going to interpret what the base means later in an application, which is really the critical part of all this. But you can see that it climbs extremely fast. Right? I haven't even made it out of 5 yet. I'm already climbing way up there. Thus, the phrase, it's increasing exponentially, meaning it's increasing fast. So what happens now? Let's look at the other scenario here, the reciprocal and 1/2. So now, of course, I have, notice the base here in the previous one. So the base in this case was greater than 1. And what happens? Well, I get an increasing function. And you can see that it is increasing 1 to 1. Okay. So what happens again, if I look at the reciprocal, same thing, I'm going to enter exactly the same numbers. Don't want to do that. Yeah, no, I'm not. I don't want to do that exactly. I'm going to go -4, -3, -2, -1, 0, 1, 2. I'm going to check these numbers out. Again, I know what's about to happen, so that's why I chose them. So I'm going to enter g of -4. So now what I have is this. Again, I notice that I have a negative here. So what I'm going to do, if I could, again, I could do this, but I'm not going to do this from now on. But I just want to show you that I can do this. I can break up the -4 to 2 parts. -1 times 4. So now I have a power to a power. When I apply the -1, it just flips everything. It's a fraction. That's what this goes in the denominator, it goes in the numerator, and vice versa. So I get eventually 2. So now what I have is 2 to the 4th, and we already saw 2 to the 4th is 16. So this becomes 16. If I keep going in the same fashion, g of -3. No, I'm not going to do that whole spiel again. But what I do know is, again, if I apply the negative to this, what do I get is 2. Leaving me 2 to the 3rd. And I already know that 2 times 2 times 2 is 8. And keep going in this fashion. G of -2. Again, apply that negative, I get 2, and that's still squared, and I get 4. You can see everything's going backwards now. g of -1. And again, when I flip this, it just becomes 2. And g of 0. So again, it doesn't really matter. That basis, I get 1. And finally, g to the first power, that gives me 1/2. G to the second power. So again, I can think of this as half times half, or if you would like, if you prefer this, give this 2 to each one, 2 to the first, sorry, 1 raised to the second power, 2 raised to the second power. So the resulting is 1/4. So g to the second power is 1/4. So I have 1/2 here and 1/4. So now I'm going to graph these. And what do I get? Okay, for -4 is 16. -3, it's right here, and that gives me 8. And notice, wait a minute, it seems like it's just flipping across this axis, isn't it? Isn't that what just happened? Yes, as you're going to see, I'll make a mention again. I already mentioned it previously, but I'll mention it one more time until it becomes obvious what's happening. -2 is 4. And you see that there's this 1 on the other side. Hopefully I graphed it right. Yes, I did. It just looks a little weird because of all the stuff on this side. Makes it look less symmetric than but it is. -1 is 2. -1, it is 2, just right there. 0 is 1, so we get the same point right there, 0, 1. 1 is 1/2. And then 2 is 1/4. You can barely read. So yeah, look at that. This thing now is it's kind of hard to do, but you see that it's trying to see if we can do a better job on this beginning curve. The trajectory anyway. Okay. Yeah, it's just a mirror image on the other side. That's all it is. But why is that happening? Because again, transformations explains this. If I have g of x equals 1/2 raised to the x power, again, notice I can always bring, what if I wanted to bring this 2 up to the numerator? Well, right now it's 2 to the first. If I bring this up to the numerator, what happens? Well, I get 2 to the -1. Then if I apply again an exponent rule, -1 times x is -2x. So now what is the difference between this function, g of x, and this other function, f of x? Well, using transformations, what I've done is negated the x variable. And we already know that if we negate the x variable, what happens? We flip across the y-axis. So right now, all we've done is flip across y-axis. So again, here's where again transformations help us make sense of certain things, and then it makes calculations easier, or it gives us choices how we are going to approach certain questions.